Hello, my name is Benjamin Barron, and I'm a sophomore at American Heritage School in Boca del Rey. And my project is about addressing the opioid crisis, development of a novel device for automatic delivery of naloxone. Our nation is facing an opioid overdose epidemic. According to the Centers for Disease Control, 47,000 people died of opioid overdose last year. 130 Americans die every day from opioid overdose. This affects people of all ages from all socioeconomic classes. The music superstar Prince died of an accidental opioid overdose because he took Vicodin laced with fentanyl. Some people overdose on illegal synthetic opioids, others on opioids prescribed by doctors. The singer Tom Petty took oxycodone for pain after a hip fracture and accidentally mixed with other medication and died. Unfortunately, opioid-related deaths also happen in hospitals due to pain medications after surgery. This could happen due to alarm fatigue. The treatment of opioid overdoses with a medication called naloxone, which is a competitive inhibitor of opioids at the site of the opioid receptor in the brain. Naloxone is very safe, in fact, so safe that paramedics and policemen now carry naloxone. However, despite having naloxone, people still die every day of opioid overdose. The problem is that the victim depends on someone else to find them and administer the naloxone in a timely manner. In this project, I designed a wearable device that a person who is using opioids would be able to wear. The device uses a sensor that monitors the heart rate continuously, and if it detects a slow heart rate, which is a sign of opioid overdose, it will notify the user and ask them if they are okay. If the user does not respond, the device will assume that the user is unconscious and deploy the solenoid to push the microneedle arrays and deliver naloxone. Since naloxone is approved only for injection or through the nose, I tested two options of naloxone delivery through the skin, a cream and a microneedle array. I used porcine skin, which is most similar to human skin, and built a skin diffusion device to test the absorption. The cream was applied through the skin for various lengths of time, and the absorption was compared to samples that I injected with a microneedle array. The high-performance liquid chromatography results indicated that the cream had more erratic absorption, and as expected, injecting through the microneedle arrays resulted in a significantly higher concentration. I prepared this clay model to demonstrate the device. This is a much more enlarged and very simplified model. The actual device is much smaller and much more complex. The idea is that the microneedle arrays at the bottom are not touching the skin. The naloxone solution will be stored inside the compartment, separated from the needles by a thin layer that can be easily punctured. The device also has a sensor that monitors for the pulse. This here represents the solenoid. When the solenoid is deployed, it will push the cover down and deliver naloxone through the microneedle array.